This video is going to look at three main points Rutherford discovered. So point number one is atom is mostly empty space. So Rutherford fired alpha particles at it. Alpha particles are nuclei of a helium, so it is charged, and most of it did not get deflected at all. It just went straight through. So let's say we're looking at a gold atom, and we're looking at the nucleus. So the nucleus is here, and most of it is just empty space. So the alpha particles fired, it just went straight through, so nothing happened. So even though most of the alpha particles went straight through, some of them, very few, went closer to the nuclei, and they got electrostatically repelled. What does that mean? Remember that alpha particles are positive charged, and because the nucleus, which is made from protons and neutrons, are positively charged as well, so there is a repulsion between them. This deflection is called electrostatic deflection, or electrostatically deflected, because the charge of the alpha particle and charge of the nucleus are the same, so they're repelling. So you can think of it as two positives repelling each other, or two negatives repelling each other. Note that this only happened to very few alpha particles, so most of them just went straight through. So the third important point is that even fewer, so some of them got deflected, even fewer bounced right back. So you had the alpha particle and it came right back. So only very few involved meant that it showed Rutherford that the nuclei must be quite small and charged. It also showed that the mass of the nuclei is bigger than the mass of the alpha particles, because it did not have any noticeable effect. So in summary, so you have a small massed alpha particle and it's coming through and it's bouncing right back. So this showed that the charges, the alpha and the nuclei, they're both same charged and they're positive, and the nuclei has much greater mass compared to the alpha particle, because when this occurred there was no appreciable effect on the charged matter. So the charged matter is in the gold leaf. So when the alpha particles were fired at this charged matter found in the sheet of gold, the nuclei wasn't noticeably affected by the alpha particle. So that is the gold nuclei is not noticeably affected by the alpha particle. And because this only occurred such a very few alpha particles, that it must mean that there's a very large density and it's very small. Because I'm talking about densities because you got a huge amount of mass in such a small volume, that the collision between, they don't actually collide, but you can think of it as alpha particles very close to the nuclei, and they bounce right back, and the nuclei of the gold is not affected by that, or noticeably affected. There will be a very tiny effect, but for our purposes it doesn't get affected.